Welcome to the AgEmerge podcast, brought to you by Ag Solutions Network. Your farming challenges are unique, so your practices should be too. We're here to share emerging ideas, build connections, and provoke conversation.
Get ready to improve your soil, your crops, your livestock, and your family's livelihood. I'm your producer, Kim Chase.
And I'm your host, Monty Bottens. Thanks for joining us.
Thanks for joining us. Today we welcome Kevin McDonald, Vice President of Customer and Government Relations at Guardian Agriculture, where they develop autonomous eVTOL systems for sustainable farming on a commercial scale. If the term eVTOL is new to you, it stands for Electric Vertical Takeoff and Landing Aircrafts. Guardian Agriculture is working to provide growers access to safe, effective, and precise aerial applications. This is an exciting discussion, so let's jump right in.
Welcome, everyone, to this episode of the AgEmerge podcast. I'm pleased to be joined by Kevin McDonald of Guardian Agriculture. Welcome, Kevin.
Thank you very much. Glad to be here. Appreciate you having me on.
Well, we've all seen a lot of news articles and a lot of fun things in regards to automation and robots, and especially drones. And probably almost every farmer has a drone now. I do. We've had them for several years. You can take some really cool pictures, and they kind of are a fun toy. But beyond that, they've just kind of lost their luster a little bit, imaging and those kind of things. But now enters the application phase. So that's what Kevin's involved with. And I'd just like for you to share, Kevin, your story personally, but also the Guardian Agriculture story. How did you get involved, and how did Guardian Agriculture get its start?
Sure. So, it's a great question, and it was actually a good lead in there. The founders of the company, were seeing what we're going on with drones, and believed that there must be some way that we can improve upon, the hobby market, which was essentially just a flying selfie stick. And how can we put them to better use? So they were exploring use cases. Adam Burkew, our CEO, grew up in an aviation business. His father owns an aviation business, and was focused on applications for this technology, and saw the momentum that had been created in Asia with drones to put them to good use, right? Asia has a real a shortfall in personnel, human resources, to be able to go out and do applications, and for some of the same reasons the United States does, and decided to focus in that area. How can we put this technology to good use in the U.S., and then exploring, what our options are to be able to do that, which ultimately, and we can talk, the different things that the company explored to get to where we are, but ultimately led to, getting a group of engineers together, robotics, electrical engineers, to build a system specifically designed to meet the demands of U.S. agriculture. Well, I shouldn't say just U.S., but Western agriculture, I should say.
Right. So that's interesting, the Asia market take on that, Kevin, because I remember quite a few years ago seeing, I believe it was Yamaha made a gas-powered helicopter, like a miniature helicopter that's remote controlled. And I think that's used in rice fields in Japan, if I'm remember, because you have your regular shapes and small formats, and especially in rice, there's no ground rigs available. So is that kind of some of that background is taking and making, instead of a large format drone that's man steered, if you will, to making that a large format automated?
Yes, that's absolutely right. So Yamaha, great idea, right? They took a system, basically a helicopter, and then they miniaturized a helicopter to be able to do the same things that helicopters currently do, or let me rephrase that, to do things that helicopters can do, but won't do in the United States, specifically vineyards. So yes, they were over there flying in rice paddies and all of that, but Yamaha is currently flying right now wine country up in California, and the helicopters won't fly there because of, just the infrastructure within the field, right? A helicopter doesn't want to go fly in a field that's got a bunch of steel posts every few feet, and it's just it's dangerous, right? But the technology didn't support, at that time, the time that they were fielding it, didn't support the level of automation that's really required to unlock all the benefits of what we can actually move towards. So Yamaha did a great job in helping to lead the way into this specific technology.
So I think one thing, and people will be able to see pictures on the links in the newsletter and show notes that we send out. But one thing I think is really unique about the Guardian Agriculture approach is that basically your size format, right? Most all of these other ones that have come into the market, I'm familiar with Rantizo and, the drone DJI sells a drone that has these small 1, maybe 2-gallon tanks. They fit in a suitcase and can go in the back seat of your truck. I got to see I believe it's SC1 model, and it won't fit in the back of my pickup truck. This is some serious hardware here. So talk about why you chose to go this larger format. I know the answer, but I think people need to know that these are the latest tricks of the trade, right? And I think we're going to have kind of another wave of people buying the selfie stick without it being as usable as maybe what they hope to. So dive into that for us.
Sure. So, going back to the lead-in that we had earlier, when Adam and the other engineers that he's friends with started exploring this, they were trying to figure out where to find the efficiencies in the available technologies for the aerial application industry in agriculture. And they looked at, can they automate existing aircraft? Can they build something similar to what Helio does? Sourcing parts from, drone markets and building smaller ones and then swarming those smaller ones? Or should they start from a fresh, clean slate? And ultimately what they found was the parts that they could source were not very well suited to the dusty, dirty environments that we currently have in agriculture. And automating large aircraft, certainly addresses the size and the scale of the problem set that we're trying to address. But it doesn't substantially improve on the environmental benefits and the safety benefits of designing a system from the ground up. So they designed the SC1. It is large. It's the frame itself is 8.5 feet by 8.5 feet, so it fits into a standard trailer or on the back of a flatbed. You can roll it down the road. But it is a large aircraft that, when loaded with a 20-gallon payload is, right about 500 pounds. So it's not small.
That's right. So it is impressive to see in person. And talk a little bit more about, hauling 20 gallons versus 2 gallons. You've got 10 times the spray time, right? What are some of the other advantages to that larger format that you've run across?
Sure. So it's really the scale, right? The smaller systems, not to say that there isn't a place for them, right? It's another tool, but they're not optimized for larger scale agriculture. So the SC1 that you referenced is designed for high volume, high frequency work in specialty, as well as low volume work in smaller acreage field crops. And when I say smaller acreage, I mean, quarter section and less. So corn fungicide applications, things like that. But the smaller systems, you have to do so many cycles, especially when you talk about, like, we'll use California as an example, 20 gallons per acre in the Salinas Valley is what they apply. That's a lot of volume to take out into a field. And when you've only got, a 2.5 to a 10-gallon tank, your efficiency is significantly reduced when you talk about high volume rates. So one of two things had to happen. You either had to scale up in size, or you had to influence the EPA and the respondents to change label guidance, right? And the second of those two is going to take a long time to address. So we designed the 20-gallon system specifically to be able to efficiently apply at standard volumes, rates, and pressures across 140 acres or less in a reasonable amount of time, and the unit economics to make sense.
Yeah, that's a great point too, because early on I had an opportunity to look at one of the startups in the small format drone, and they were talking about how, I asked a question after their pitch. I said, "Well, they had talked about selling the AI, the active ingredient, as essentially like a printer cartridge that you would put on the drone and it would interchange. So you'd be spraying basically straight, material." And I said, what about the EPA regulations? You got a certain amount of water required to apply. And they just looked at me like a deer in the headlights. Look, they'd never even heard of that before.
Mhm.
I mean, how could you not know that if you're entering the space, right?
Yeah, there's two different types of people looking at this, right? There's in the ag industry, there are the growers and the applicators that they just need to be able to get the work done, and they understand, but they don't necessarily understand what are the best tools, and then that goes to the second part of this, which is the UAS industry has not been completely honest, and not forthcoming about what data sets are we going to use? Are we going to standardize data sets across the various types of equipment? Are we going to tell the truth? Like, I can tell you that the SC1 is not optimized for broadacre agriculture. That you can use it, but there's probably a better piece of equipment. Some of the other competitors out there probably don't want to say that because they really just want to be able to sell systems. So we've approached this from the standpoint, and my short background in agriculture, I learned very quickly that relationships are what you build and drive this industry. And if you cannot build trust in your relationships, ultimately you're going to fail. So like my title, I'm in effectively sales and regulatory. I'm an operations guy. And it just turns out that being an operations guy in agricultural sales is actually a benefit, because I'm going to tell you if our product is going to work or if it's not going to work. And then I can make recommendations. I'm building that relationship because I know over time, if our current offering doesn't work for you, very, very likely that in the future, we're going to have something that's going to solve your problems. And I've got, a good connection with that individual to go back and revisit how we can make things better.
I think that's a great point. Too many people just try to sell what they have and hope it fits everything, where it's better off long term, because farmers have the memory of an elephant, right? Never forget.
Yes.
And I think it's always best to say what you can do and what you can't do. And if you can't do it, be honest. And I appreciate that approach. One of the things in talking with your pilot when I went to see the unit fly there in Salinas was, he says, "Hey, on your broadacre crops, or you got a flat square field that, no power lines, no trees, no buildings, no problems, to do that with this type of format 100%, it doesn't make a lot of sense." But I thought he had a very interesting point in how you're looking at integrating air tractors with the drone. So the drone would basically do field edges, because, that way we don't miss any spots if we hit the switch too soon, too late, or do corners of the field around houses, or do wrong tree lines or irregular shapes. So then the air tractor can just come in and buzz the meat of the field, if you will, real quick. Talk about that strategy and what you've seen there and how that improves efficiencies for the applicator.
Yeah, it's a great point that Chris made, and I'm glad that he brought it up. So, even in the broadacre market, as he said, our system isn't designed for full field coverage, but it certainly does improve safety. So, before coming to garden and agriculture, I ran the aerial business for Wilbur Ellis for 2 years, and I understand the risks. Being a pilot myself, I understand, what it's like in the cockpit, but I also understand the risks from a business perspective. How can we make things better? And that particular use case in this particular instance is absolutely appropriate. You've got in a regular shaped field with power lines on one side, a stand of trees on the other, and it's difficult, right? You're not going to get edge to edge coverage with a helicopter or with an aircraft, and that application quality is going to vary by the pilot, right? So what one customer that we have is not true broadacre, but he's like, Kevin, he's running a fleet of helicopters. He's like, I want an 80 acre rectangle for my helicopters. So I want to use these systems to go in and paint the edges so that I can send the helicopters in to do the easy part, which is the middle. The 80 acres, perfect symmetrical rectangle, and basically using each tool to its maximum potential to increase efficiency for existing operations. And if there's any instance of needing to go back and do cleanup, he sends one of our units back instead of sending a helicopter all the way back. So and you can translate that across broadacre, specialty, aircraft, ground sprayers. It doesn't really matter. It's really pulling apart the use cases and then understanding how to best use the tools that you have to make your operations as efficient as possible.
And that edge to edge that you're mentioning is so important for example of spider mites, because they typically start at the edge of the field, and where is the spot that's hardest hit aerially is the edge of the field, because we don't want to get too close to an adjacent crop or a road, those kind of things. So I think that or thrips or those kind of things that might come in from a field edge, that's a big deal. Plus the smaller format than a 60 or however wide the pattern is on an air tractor. You look at almonds, for example, typically 2 or 3 varieties in every orchard, and they all bloom at a little bit different times. You could send the mission out to spray just the nonpareils this day, wait for so many growing degree units and spray the Monterey's, at a later time, because you can basically go row by row.
Yeah,
I mean,
absolutely.
it's interesting.
It is. And, our CEO has a saying, and it's funny, but it's absolutely accurate, is that we've designed and built a system that is capable of painting a Mona Lisa on a field, but everybody wants a black canvas. So it can do either, right? It can paint that black canvas and cover the field with 20 gallons per acre on every single acre, all the way up to the edge, uniform, and the same way every time, so you get the same spray quality. Or it can go out and do exactly what you said, which is pinpoint specific swaths or specific pinpoint areas. It's a robot, so it does exactly what you tell it to do.
We're taking a short break to share that the AgEmerge podcast is brought to you by the team at Ag Solutions Network. Rooted in innovation, ASN is committed to leaving the land better than we found it, not simply maintaining it. We're here to help you navigate the balancing act of productivity and building a legacy. From practices to products, ASN is more than a new jug. It's a new way of thinking. So don't be afraid to be different. Be afraid to be the same. Contact Ag Solutions Network today at asn.farm. And now back to our show.
So let's talk about the cool geeky stuff now a little bit.
Sure.
We got to get our fix there. So it's all automated, right? So if you say there is a corner of that field you want to spray, you can draw that, I assume, on some sort of application. It will pre-plan the flight and it will just go fly that corner and come back, correct?
Correct.
You're not, the only reason you got there with the joystick is if there's an oh crap moment and you need to take control, right? But other than that, it flies the mission 100%.
It does everything, really. And so I'm a Marine, and the joke about Marines is Marines teach a Marine to make crayons, or give a Marine a crayon, he'll eat for a day. Teach a Marine to make crayons, and he'll eat for life. So like, Marines are, among the services, we're the knuckle dragging, crayon eating, window lickers, and I came into the company and I said, look, guys, you're building this machine for me. And you need to be able to build a system. Engineers are great at building systems for engineers. They're not always so great at building systems for operators, right? We just think differently than they do. So we need to make this thing as not just safe, but also easy, simple interface. So the interface with the pilot is, just the mission planning side of it. You go in and you import the shape file. You set the boundaries. You input the hazards, tree lines, power lines, Met tower, whatever it is, wherever you need to stay away from. And if you want to do the whole field, you send it, right? But if you want to do specific areas, if you've got a pest pressure map or something like that, then you can map it out, and the software will pick out that specific area. And once you hit go, it goes. There will be backup sticks, but the engineers can engineer to solve 95% of the problems, but that last 5% is next to impossible to engineer out. Like, we're going to spend so much time and money trying to solve that problem, when really, it's just a wasteful effort, right? So, for instance, DJIs will go out and they'll be spraying a fungicide application on corn. They'll come to a waterway. They'll dip down into the waterway, and then it sees a stand of corn in front of it, and it can't go anywhere. Doesn't know what to do. So the pilot's got to take over manually, tell it to climb back up, and then continue on the way. Like, you can put that waterway in to our software, and it knows it's got a backup. When it sees the crop canopy drop away, it knows, hey, I'm not descending down into that. We can solve for things like that. We can make it better, but we can't solve for all of them. Typically, what the pilot's going to do is interact with the aircraft with a handheld unit, which just has a few selections, which is pause. Hey, I want to hover and turn the spray system off while I figure out what's going on. Land in place, land right where you are because something bad's going on right now, whatever. Or return to land, which is, hey, come back here and land back on the trailer or the truck, whatever you've got. And then, the fail safe, obviously, this is an electric aircraft, it's a robot. You want to be able to disarm the motors as quickly as possible. So we've got an emergency stop button that physically disconnects the propulsion battery from the motors. So the motors immediately stop, which is critical for ground operations, right? You don't want someone walking up to the aircraft when those motors are powered. You don't want those blades spinning up, because they're right at about, depending on how tall you are, waist to chest high. So yeah, got to be able to ensure that there is no physical connection between the propulsion battery and those motors. So that, other than those four options, it's just, send it on its way, and you essentially become a loader. You recharge the battery and you refill the payload, and it does everything else for you.
So that's the next thing I wanted to talk about, is recharging a battery. So most of us are probably familiar with the smaller formats, or have owned one where you're pinching something, pulling a battery out, putting it on a charger, putting the charged battery in. That was one of the things that just kind of surprised me at first, is it has an onboard battery. And I'm thinking, oh boy, how long has it got to sit at a Tesla Powerwall to recharge for a flight, right? But that's pretty amazing what you guys have come up with on the charging system there. Walk us through all that, why you went with the onboard battery, size and those kind of things, and then how you recharge it in the field.
Sure. So two reasons there. One's efficiency, and the second is safety. I'll address the safety first because it's easy. A battery is in these machines is the propulsion system. It is the fuel source, and I would not want my fuel source for an aircraft failing mid-flight. When you take a battery out in a dusty, dirty environment, you're collecting dust, dirt, and grime on those battery connections. uh, and you don't know when that connection is going to fail, and you just fingers crossed it doesn't fail when you're in flight, right? These machines are much larger than what folks are, you know, tend to be using. So we don't want to go tear up a field with you know, an aircraft that's tumbling through, you know, strawberries or corn or whatever it is. So we decided to integrate that battery, which created the second issue that we needed to solve, which is efficiency. If you're going to keep the battery integrated, right, you've got less infrastructure, less equipment that you're going to have to maintain. You just need a charging system, which makes it clean and simple. It's easy, but you got to be able to charge it fast, because nobody's going to deal with, you know, a 30-minute, 45-minute Tesla charge time. And we couldn't find a battery commercially available that was able to charge at the rates that we wanted to. So we've got some really smart electrical engineers that did their homework and you know, crunched some numbers, and found that we can build our own battery by modeling what Tesla did with their batteries, which is sourcing cells and then building the battery ourselves in such a way that it can accept a very high rate of charge. So we've optimized our battery for energy density to be able to lift a heavy load, fly, dispense that load quickly, fly back, and then accept a very fast charge rate. So we charge at for the engineering types that are out there, we charge at a 5C rate, which is basically 5 times faster than what Tesla charges right now. So that aircraft comes back on say an 8-minute flight, or we'll continue. We'll use 8-minute flight for corn fungicide applications. So comes back from an 8-minute flight, lands, and we achieve a 2 minutes of flight for 1 minute of charge. So that 8-minute flight is going to take 4 minutes to recharge while the tank is refilling, and it's going to go back out. If you just hear it in that context, it's like, well, that's a long time on the ground. But when you start talking about, you know, that would be a low volume work situation. So a corn fungicide application, you've got a 20-gallon tank at a 2-gallon rate, which is the label for aerial. You're going to empty that tank over 10 acres in 8 minutes. It's going to come back, land. You're going to start refilling the tank and recharging the battery, and 4 minutes later, it's going to go back out, and it's going to basically repeat that process over and over again. The efficiency that you gain with that high rate of charge is 45 plus acres per hour. That includes the tending time on the ground. So from the time you pull up to the field to the time you pull away and that field's complete, you're netting somewhere between 45 and 50 acres per hour. It just depends on your ground setup.
Yeah. And, you know, one of the things too that, you know, they're mentioning, just the sheer size of that battery, over 100 pounds, just awkward to exchange to. But I think that's impressive if you can charge it twice as fast as you burn it, essentially in the air. That's wonderful. And I also see where you could do 2 of them in tandem, one flying, one charging and filling, and still, you know, have the resources to keep them both moving at the same time. So
absolutely, yep, yeah, agreed.
So that's fantastic. And then a little bit of engineering went in to figure out how to do that in a remote location, right? So, you know, you have a truck specially set up with that, with a charger that had never been done before, or something that I understood. Talk some of that. That's kind of fun to hear what you go through to figure these problems out.
Yeah. So one, we designed the battery. Then we've got to figure out how we're going to charge it, right? Because you've got to get a lot of juice in there through the supercharger. So we've got to figure out how to build a supercharger, one, to be able to really jam that energy into the battery. But two, now, okay, we got that built. Where are we going to get the power? And it needs not an insignificant amount. All right, so we need 70 kW to be able to charge the maximum charge rate. But we've figured out that a PTO generator works great. So we've got 2 different trucks. We've got an F550 and an F350, and they're both capable of running the same PTO generator, but that PTO generator off of either one of those two trucks provides 70 kW of power to the supercharger to supercharge the battery. So it was a probably 2.5 year effort to get to that, where we've got the battery, the supercharger, and figuring out how we're going to get the power to the battery or to the supercharger without having to haul around a standalone generator on a trailer, which is that would be silly.
Well, and plus that's a big generator too. So those are some impressive numbers, that's for sure.
I think, sorry to interrupt, Monty. One thing that I will say is we didn't stop there, right? So the future for this, for those customers that want it, right, it goes into the sustainability and environmental friendly of this is, again, taking it one step further and saying, hey, we want to build a battery pack to supercharge the aircraft. So essentially, our roadmap has a trailer that is a battery pack. And we take that level of automation that we were discussing earlier one step further, where we fully automate not just charging, but also refilling. The aircraft comes back, precision lands on the back of a trailer, mates with a system that will then fill the tank and recharge the battery without the need for a generator, because the trailer itself is the battery pack, and it just sips off of that battery over the day. And then at the end of the day, when you're done, you take it back home, you plug it in, and the trailer recharges overnight, and you're all ready for the next day.
No, fantastic. And I really like the idea of the automation of the connection of both the fluid product and the power. That'll, again, eliminate a person. So you can have one pilot monitoring the machine, and everything else can pretty much be automated. So that'll really improve that time, because the time on the grounds, or the time stopped on the end of the field, whether it's a planter, a sprayer, or the Guardian Ag SC1, all of them, that's the least productive. So I wanted to jump in a little bit, your regulation hat. I know this is always fun, because
yeah.
I have a saying: government moves at glacial speed. And these new technologies are so far on the edge or the fringe of what the government regulations are. I mean, there's been lots of exceptions made in that. Talk to us about that regulatory climate, what a person needs to have as far as a pilot's license or not when they're doing this, and what that looks like in the future as drones become basically mainstay.
Sure. Yeah, regulatory, that's a beast, to say the least. So, there's two different levels of the regulation, right? There from an aviation standpoint, I should say aerial application standpoint, right? You've got the federal level, and then you've got the state level. So at the federal level, really, that's been our struggle the last many years. The FAA is undermanned to deal with this emerging industry. There are so many applicants and so few staff to process every application that comes in. So when a company wants to fly a drone, whether it's a small one or a large one in a commercial capacity, they have to apply through the FAA to be able to do that. And you can imagine with all the drones that are out there right now, how many applications are coming into the FAA. And as the drone sprayers are coming into the market, we're seeing more and more of those. You can imagine everybody that wants to fly one has got to apply at the federal level for Part 137, which is the federal aviation regulations for aerial application of agricultural products. So they're dealing with a lot. So what we did was we applied for getting approval, one, to be able to fly the aircraft in a commercial capacity, right? It's a brand new aircraft. It's got to go through airworthiness inspections. It's got to go through, they got to look at the concept of operations and the operations handbook that we made, and the maintenance handbook that we made, all of that, right? To be able to ultimately arrive at a decision to say, yes, Guardian Agriculture, you are we believe that what you have created here is safe to fly in a commercial capacity. We're not there yet. We are very, very close. We're told that it's in the final stages of signature, so we should expect some big news coming here this spring. I know we're actually technically already in spring, but so that was one hurdle that we had to overcome. The second one is applying for the Part 137 to be able to spray in agriculture, and we are, I guess, less than 2 months away from having that as well. That one's a little easier to follow and track. And for those of you that are out there listening to this that have drones and have applied for a Part 137, understand that you can ask where you are in the queue, and they'll give you a number. Right now, the FAA is processing somewhere between 20 and 25 Part 137 applications per month, and you can basically extrapolate over time using that math how far away you are from getting an approval for a Part 137. So I think we were number 35 the last time that we checked. So
How are they going to, I mean, with all the drones that are going out and being available, how are they going to ramp up to meet these applications? Or are they just going to say, oh, no 137 needed? I mean, what? This is going to be a real problem, right?
You're absolutely
bottleneck
right.
to your sales.
That's well, no, I don't think so.
Okay, good.
There are two things, and I'm glad you asked the question because I was building to it. Was how do we help the FAA understand what's appropriate to analyze in these particular use cases? It's new technology, right? So we were fortunate enough in drafting our documents and interacting with the FAA that the FAA was really impressed with what we were doing. They chose to partner with us in what they call the Integration Partnership Agreement, which used to be called the PSP, the Partnership for Safety Program. Essentially, what the FAA said is, "Hey, Guardian, will you help us? Basically identify what standards and what metrics need to be met." So, how do we understand that this particular aircraft or that particular aircraft is safe to fly? How do we understand, what training is required for these pilots? What should their operational procedures, whether they're, field operations or maintenance, what should that look like? What should their documentation look like? Things of that nature. So we've actually got some ability to influence the way that the FAA operates. And my hope is that over time, we're going to see a lot of those barriers come down, especially in agriculture, right? It makes sense to be able to lean into the agricultural side of this piece. Everybody's talking about urban air mobility and package delivery, and that's inherently dangerous stuff. We're talking about flying drones over people or flying people in drones over people. And here, all we're asking to do is be able to apply crop inputs in a smarter and safer way than is currently done. Not to say to replace anything, but to be able to do it in a smarter way when it's warranted, in an area that is unpopulated and typically rural. So the FAA recognizes this. We're helping them build a path towards it, and hopefully we'll see over time that the Part 137 applications and what we call the 44807 applications, that those timelines come down significantly. What we're going to do for our customers is when a customer provides or purchases a system from us, we provide all of the regulatory assistance. We've applied for all of the exact same things that our customers are going to apply for. We know what particular things our customers can reference in their applications to expedite the process. We provide them with templates of what they need to apply with those forms, pre-filled, basically. Just it's like a Mad Lib for FAA applications, and we time those applications so that when they take delivery of a system, they are full up and ready to go with regulatory approval. And we're able to do that because we understand and forecast out our manufacturing queue and know generally when those systems are going to be delivered. So we make that application. We just backwards plan effectively.
Yeah, yeah, that's great. So that way all the slots are lined up and it's ready to go. So speaking of that, Kevin, we've got 10 people are listening here that just want to have one of these cool tools to put to use, and they're just waiting to write a check. When is it available? What's the commercial launch date and those kind of things looking like at this moment?
Sure. That's let me get to that one on a question in just a second, because I
Okay.
didn't answer the second part of your question, and which is common among our customers. What do I need to be able to fly this thing? Federal level, you need a Part 107 license, which is a drone pilot's license. That's easy. Study for a weekend and take a test with the FAA. You need obviously a valid driver's license, but you also need an FAA medical certificate, which is easier to get than a DOT medical. You just go in. It's a physical examination by an FAA doctor. And almost all cities have those guys around, so you can look them up. But from a state perspective, it's a little bit different, right? Some states differentiate between aerial application and ground application. You'll need an aerial applicator, an aerial pesticide applicator's license if your state differentiates between the two of them. And for those that don't, you just need a pesticide applicator license. California is the hardest. We do get this question. Right now, and we're working on changing this. To be an aerial pesticide applicator, you need a pilot's license, or you need to be working under someone who is a pilot. So we are currently brainstorming ways to help our customers in California how to not to get around the regulations, but comply with the regulations and be productive. So that answers that question. For the one that you just asked, for the manufacturing, if a customer is really interested, wants to learn more, they can reach out to me directly if they have more questions, or if they already know. You're one of those folks that I met at any one of the trade shows that we've been to. You can go to the website, guardian.ag, guardian.ag. And we've got it set up so that you can reserve now. If you're a small grower, or a small co-op, and you only want 1 or 2 systems, you can make a refundable deposit directly through the website for those systems, and you'll be hearing from me in short order to really connect with you and find out more about your use case and give you a rundown on when you can expect those systems. If you're a larger co-op, a retailer, something, aerial applicator, we've got all of those customer types. Typically, we don't take those through the website. Those are done via invoice. The website's not really optimized for more than 1 or 2 of those deposits. Right now, this is a good problem to have, but also kind of disappointing to have to tell potential customers, is that our manufacturing right now is backed up through 2025. So there is a lot of demand for these systems. Through the demos and discussions that we've had with folks, they recognize that what we're building is aviation grade. It's not using hobby grade parts. It's a durable machine that was purpose built for your use cases, and is likely to withstand 5 years the environments that they're subjected to. So we took the same approach that American OEMs do with tractors and ground rigs. We built a piece of farm equipment. So that's where we are currently. Hopefully over time we're able to scale production in such a way that those times come down significantly.
Well, that's great. I mean, you've dealt with your fair share of challenges too, with electronics shortages and supply chain craziness, and coming out of COVID. All those things have really affected ag tech startup companies just in general. So I'm glad you survived. Glad you're on track to keep moving forward. So
can I jump in there 1 second, Monty?
Yeah, go for it.
The supply chain's a great point to just touch on.
I heard this.
Um,
This is amazing. Look, at the field day, I just thought it was really interesting where you source your parts from.
yeah, so we are an American built system. And you're right, we did experience some supply chain disruption. But thankfully, our VP of electrical engineering, Dan Landers, did a great job in exploring um, supply chains and was able to determine, basically did a build or buy analysis, right? Can we build it in-house? And if we can't, how can we keep the supply chain as short as possible? So in the instance of power control boards, we can't build power control boards, but we can assemble them. So um, we're sourcing our power control boards from a company that's 15 minutes away from our engineering headquarters. And we basically can just drive over, pick them up, and then start assembling them. And we do that with all of our parts. If we can't build it, we source it within the United States. And those parts that we cannot source are in the United States, we don't go across the Pacific. That's an incredibly long supply chain. We go to NATO countries in Europe. So our motors, our propellers, they come from NATO countries in Europe. But aside from that, very, very few pieces come from outside the United States.
That's a phenomenal approach, and I really wish others would really look at the risks involved with, uh, having those. Cheapest isn't always the cheapest, is it? So
No.
that's I'm glad you guys had the forward-looking vision to do that. So that was my next question. You got your crystal ball there on your desk right now, Kevin? Can you polish it
I got,
off and
I've got an iPhone. Maybe I can download Magic 8-Ball.
Yeah, it'll probably tell you what's going to happen. But where do you see this? Where do you see this being at in 10 years? Use of drones in agriculture. What's your vision of it?
There are folks out there that think that this is going to replace many parts of how we currently apply crop inputs, and I think that in some use cases that might be true, but it's not wholesale replacement, right? So one of the things that I tell folks that I talk to is this is a tool. A carpenter does not go out with just a saw and a hammer. Carpenter goes out with a tool belt and a toolbox and chooses the right tool for the right job. I think in 10 years, certainly this technology is going to scale larger. This is the smallest system that we're making. We're not going smaller. Smaller already exists. There's no reason to go backwards. We're going to develop technologies that are able to address broader acreage units. But when you start talking about one-to-one comparison against an AT-802 or something like that, like we're not carrying 800 gallons worth of stuff, but certainly we can design systems that can put a dent in the broadacre market, or be able to take fields that are just not optimized for larger aircraft. 10 years from now, I think what you've got is fingers crossed, every grower has access to precise, reliable, and transparent aerial application with an unmanned system. Doesn't mean necessarily that every grower owns one. We make it easy enough to use that they could, but just like the ground sprayers, not every grower owns a ground sprayer. And I think that that's the important piece here, is being able to have access to reliable, repeatable, and transparent aerial applications, so they know it's going to be there when they asked for it to be there. It can, repeat the same application every single time without variation. Once you've got that recipe dialed in, it goes out and it applies it the exact same way every time. So you don't get, missed edges or, variation in the application quality. It's the same. And then last is transparent, so that when they ask for 5 gallons per acre or 20 gallons per acre, they know at the end of the day, they're actually getting that amount that they asked for. And those are the 3 things.
That never happens, Kevin. Come on. Oh, geez.
I know it does.
I currently have a high clearance ground sprayer because the transparency was an issue with an aerial applicator. Okay.
Yep.
So to get an as applied shape vial out of an aerial applicator is sometimes like pulling teeth.
Yep.
And, it's amazing the tank always empties. You just don't know where it empties at. But there's lots of stuff that happens. And that is a great point. So the things I like about it is, distance off the canopy that you can maintain, the constant flight speed, irregardless of your tank fullness, and especially when you get into variable terrain, being able to go up and down following the hills. It just can't happen when you're flying 150 mile an hour and have a full tank on the front. So those are all great things. The other thing is I like how you said when you think about it now, everything that needs to get sprayed is being sprayed with
Right.
something, right? So is this a better option to do something or allow us to do more? And I think it will. And I hope that we can be at a point where, instead of having the self-propelled sprayer, maybe it could be economical for a mid or large farmer to have one of these to do all of their spraying with, essentially, especially at the 50 acre per hour. Hey, we're within the range of, a mid-sized self-propelled sprayer. So that is kind of interesting. So then the question becomes do you think the autonomous ground rigs versus autonomous drones, how will that shake out? You given any thought to that?
Played the fifth.
Okay.
No. I think
Just need to say, hey, that crystal ball, it's a little murky.
Yeah, it is a little bit murky. I hear both sides of that, right? And I tend to be the person that thinks, look, this is like I said, 5 minutes ago, this is a tool. But there are people that believe that this is going to replace a large portion of ground spraying. And I understand that statement. If it's not wholesale replacement, large replacement of ground sprayers, when we're able to scale the technology to a level that it can compete on a one-to-one basis with all ground rigs that are out there, you simply, if I asked you, Monty, I've got this system over here that's never going to touch the ground and can apply and get the same effects as the rig that you're putting into your fields right now, but you're not going to have ground compaction. What are you going to do? Not everybody's going to say, I'm not going to use a spray rig. But I think a very large portion of people are going to understand, their yields are going to improve over time if they're not experiencing that ground compaction. You're not bringing in weeds on the tires. You don't have to deal with transporting it, right? I heard was it World Agritech last month, I think it was, or earlier this month. And I heard a stat on ground rigs for, the custom applicators are out there. 30% of the time that those rigs are in operation is productive time. The other 60% of that time is not. It is sitting idle, running, or it's transiting between the barn and the field. That's a lot of time on that machine that is not going to productive use. So I see both sides of the argument.
There's a compaction issue for sure, but I think there's something else, crop damage, and final thing is operator safety. That operator is anywhere from 100 to 2,500 feet away from the point of application. And I think that's a big deal. Instead of operator having to be in a cab surrounded by the plume and, volatile particles there, that's definitely a plus. So, but no, it's interesting to see, and I hope everyone will take a chance to go to your website and check it out. I've got kind of a list of some fun questions to go over here in our after the show and see. But anything else that you want to add that I should have asked here today, Kevin, while we're together?
No, I think the questions you asked are great. And again, just happy to have been able to speak here. I appreciate you having me on.
It's been a fun journey to see you guys. I remember bumping into you first time. It was at Farmers Business Network almost 5 years ago with the 6-rotor machine and seeing you, what you've come to and all the developments you've made to make this possible. I think it's pretty amazing what your entire team has done. So congratulations what you're doing and really allowing us to be better stewards, because we'll be able to apply what we need, when we need, exactly how we need it. So less total impact and lead us to better management. So yeah, thank you, Kevin. I really appreciate it. Pass that along to the kudos along to the entire team, please.
Will do. And looking forward to getting out there on the fields this summer.
Thanks for listening to this conversation today. The AgEmerge podcast has made it a priority to explore ag technology that can help us to adopt practices that ultimately help to improve soil health. It's exciting technology, and it's great to see these advancements. And as always, if you'd like to learn more about what we're doing to help growers implement soil health practices, check out our website at asn.farm, and there you can click on links to follow us on Facebook, Twitter, Instagram, LinkedIn, and YouTube. There's a lot of great things happening and always something to learn. Thanks for listening.